Going on in day 4 here. So we have this list of strings, and we know that the list contains 3 things. It has this name, and then a dash, and then a sector ID, and then a checksum. And it's always the last dash that's before the sector ID. There can be other dashes too. So for part 1, we are supposed to compute the 5 most common characters in the name. Tie break smallest character first, or first alphabetically, and compare that to the checksum. And add together the sector IDs of the rooms where the checksum matches. So we parse out the last dash, and the name is everything before that, and then we parse out the left square bracket, and the sector is everything before that, and the checksum is everything after that, and then we delete the last character from the checksum, which is the right square bracket. Then we delete all the dashes from the name, and we're going to compute the frequencies so that we can compute the checksum. So go through and just create frequencies for each character, and then sort them according to the tie-breaking rules, which is the highest frequency. So sorted is going to return the list from lowest to highest. So we want to negate the frequency so that the highest frequency will come first. And then the second tiebreaker is just the character itself, right? Alphabetically, first character should come first, and that we don't need to negate. That those are already smaller. Like A is already smaller than B. So then checksum is just the first 5 characters. This just converts that into a string. And then this is for part 2. So for part 1, if our checksum matches the actual checksum, then add the value of this sector. And so that's part 1. For part 2, we are supposed to decrypt the names and figure out which one is the North Pole object store. So the way that we decrypt the names is we rotate the letters by the room sector ID. So we've already stripped out all the dashes. Those are supposed to be spaces, but who cares? So grab the numerical representation of the character. So this is the ASCII value corresponding to the character. Subtract A. So now we have a number. Now we have between 0 and 25. We're using the fact that all the characters are lowercase English here. And then add the sector. And then mod 26 gives us something back 0 to 25. So now we've rotated by the sector code. And then add back the value of A to convert it into like a real ASCII thing. And then convert it into a character. So ORD is Python's function that takes a character and gives you the ASCII, and CHR is Python's function that takes an ASCII value and gives you back the character. So now we have the decrypted name, which I've called real name. And so part 2 is not actually very clear. It doesn't tell you what name you're looking for, but I figured that if we're looking for North Pole objects, then the string orth should be in there. I used orth instead of north in case there's any like capitalization issues, although of course everything's lowercase, so that was silly. Anyway, if orth is in there, then let's print that one out. And hopefully that'll be there will only be one, or it'll be easy to tell just looking at it. And indeed, if you run this, it is easy to tell. There's only one object, and it's called North Pole Object Storage, which really sounds, like the answer, and it has some code. And just so we have a solution that actually prints out the answer to part 1 and then the answer to part 2. Beautiful. 158835993.